In a previous screencast, I broke down or found the components for a vector which had a velocity of 40 meters per second at 30 degrees above the horizontal, and I found that it had a vertical velocity of 20 meters per second and a horizontal velocity of 34.64 meters per second. I have shown that in another screencast. Well, what we can do here is we can use this to find the range of a thing. Let's say it was Captain Marvelo, who is a human cannonball specialist, and he really wants to know how far down here, this side here, he should put his catch net. This matters big time, so we need to find the range from there to there. Well, what we do is we can break one big hard problem into two easier ones. For the kinematics, we have the horizontal distance. We might break this up here. We have horizontal and vertical. We have the horizontal distance, the initial horizontal velocity, the final horizontal velocity, the horizontal acceleration, and the time taken. We also have in vertical, we have the same quantities. I'll use a different color for them. We have the vertical distance, the initial vertical velocity, the final vertical velocity, the vertical acceleration, and the time taken for it to stop. At university, they tend to use the symbols S, U, V, A, and T for these things, and I'll just put them in there just for completion. Horizontally, we'd love to know that. We know the initial horizontal velocity, which is 34.64 meters per second. We know the horizontal acceleration for a projectile is 0, so the final velocity will be the same as the initial. In order for us to find the horizontal distance, we need to know the time. We can't do anything with that just yet. Vertically, we know it's going to go up and come back down and land on the ground, so the final distance traveled will be 0, or actually the displacement. The initial vertical velocity is 20 meters per second upwards. We'll call that a positive. The final vertical velocity will be negative 20 meters per second because it is symmetrical and it's coming down. The acceleration is actually negative 9.81, but I can't be bothered with that. We'll call that negative 10. That's within 2%. And with a little bit of luck, we could use this here to find the time. On the next slide, and I'll come back to this one, we can then use the formula. The final velocity is equal to the initial velocity plus acceleration times the time. So we have the final velocity is equal to the initial velocity plus the acceleration times the time. We do a complicated step called swapping sides. So, plus acceleration times time is equal to the final velocity, and then we can subtract initial velocity from both sides. So that cancels with that, and then we can have AT is equal to VF minus VI, and we can then divide both sides through by the acceleration. So the time taken should be the final velocity, which is negative 20, minus the initial velocity, which is positive 20, all divided by the acceleration, which is negative 10. We get negative 40 divided by negative 10, which is 4 seconds in total. So we come back to the previous one, we'll find it took 4 seconds to go up and then 4 seconds to come down. Well, when it is finished traveling horizontally, vertically rather, it is also finished traveling horizontally, so these two numbers will be the same, 4 seconds. Then we can say that the final velocity, the final horizontal distance will be equal to the horizontal initial velocity times the time plus a half a t squared, but the acceleration is equal to 0, so that term goes, and the final distance is equal to 34.64 times 4, and my assistant with the calculator will tell me that should be a little bit under 140, I would say. 34.64 times 4 138.56 meters. So that's 138.56 meters. So Captain Marvelo needs to place this thing here, 138.56 meters from the launch point. Otherwise, he's going to get a headache.